Hello everyone, myself Vinay Kumaram. I'm actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. Coming to the fourth question in this particular exercise, again here they have given different terminologies and you should actually explain these particular terminologies giving an example. So coming to the first question in this particular fourth question, that is A question, there they have given saturated solution. So you should actually explain what do you mean by saturated solution with an example. So now any solution which cannot accept more solute in it, or if there is a maximum amount of solute dissolved in this particular solvent, so maximum solute in a particular solvent will actually generate this particular saturated solution. So coming to the example, 36 gram of NaCl can be dissolved in 100 gram of water. So if you refer the previous question, there they have given maximum solubility of NaCl is 36 gram in 100 gram of water at somewhere around 293 Kelvin. Somewhere in the room temperature, that is at 298 Kelvin. So 36 gram of NaCl can be dissolved in 100 gram of water. So there you can form a saturated solution of NaCl. So coming to the B question, here you should explain what you mean by pure substance. So if you refer my previous video, you can actually explain what you mean by pure substance. So in science, pure substance is that particular substance which doesn't have any other composition and which maintain the same chemical property throughout that particular substance, and also same chemical formula will be there throughout that particular substance. So for example, if we consider pure water, that is distilled water, so here I am taking example as distilled water. So this particular distilled water doesn't contain any kind of minerals, salts or any kind of other substances in it. So this is purest form of water. So in this particular water, everywhere you can just find H2O as its chemical composition. So there will be no other chemical composition, only H2O composition will be maintained throughout the water. So that's why distilled water can be known as a pure substance. Coming to the C question, there they have asked what do you mean by colloid. So colloid is a heterogeneous mixture of solute and solvent where there is uniform distribution or uniform dispersion of solute throughout that particular solvent. So there will be uniform dispersion of solute. So uniform dispersion of solute in a solvent. So here colloid is a heterogeneous mixture. So colloid is a heterogeneous mixture where there is uniform dispersion of solute in that particular solvent. So example for this particular colloid will be milk. This particular milk contains lot of fat molecules in it which are not homogeneously mixed in that particular milk. They are heterogeneously mixed but they are finely dispersed throughout that particular milk. So milk is an example for colloid. Coming to the D question in this particular exercise, that is suspension. So what do you mean by suspension? So suspension is an heterogeneous mixture where the diameter of that particular solute will be larger and it will easily get settled at the bottom of this particular solvent. So for example, if you put sand in water, so example will be sand in water. So when you put sand in water, this particular sand will get settled at the bottom of this particular water. So this process of settling down of a particular solute in this particular solvent can be known as suspension. Coming to the fifth question in this particular exercise, there they have given certain mixtures. You should actually name those mixtures are homogeneous mixtures or heterogeneous mixtures. So first mixture which they have given is soda water. So soda water is an example for homogeneous mixture. And the second substance which they have given here is wood. So wood contains lot of compounds which are not homogeneously mixed with each other. So hence this particular wood can be known as heterogeneous mixture because wood contains lot of fibers, lot of air molecules, water molecules, so many other chemical compounds in it which are not properly uniformly distributed throughout that particular wood. So that's why wood can be known as heterogeneous mixture. The third one which they have given here is air. So here air is a homogeneous mixture because air contains so many gases in it and these particular gases are homogeneously mixed with each other. So air can be known as homogeneous mixture. So coming to the next mixture where they have given soil. So in soil, there will be lot of elements which are mixed in this particular soil, not homogeneously. They are mixed in different ratios. So that's why soil is an example for heterogeneous mixture. So coming to the next mixture, that is vinegar. So vinegar is also an example for homogeneous mixture. And the last mixture which they have given is filter tea. So unfiltered tea is an example for heterogeneous mixture, because still that particular tea particles will be there in that particular tea solution. But when you actually filter out that particular tea from that particular tea particles, at that particular time filtered tea will not contain any kind of bulk tea particles. So because they are all removed through the process of filtration, so that's why it is known as filter tea. So hence filter tea will be an example for homogeneous mixture. Coming to the sixth question in this particular exercise, how will you identify a colorless liquid as a pure water? So to identify colorless liquid as a pure water, you should actually boil this particular colorless liquid. So when you actually boil this particular colorless liquid, if it is evaporating exactly at 100 degrees Celsius, that means if you keep thermometer in this particular colorless liquid and this particular temperature in thermometer is not crossing 100 degrees Celsius and it is exactly at 100 degrees Celsius and this particular liquid started evaporating, then you can confirm that this particular colorless liquid is a pure water, because pure water has boiling point at 100 degrees Celsius. Coming to the seventh question, here they have given certain substance. You should actually identify whether this particular substances which are given in this particular seventh question are pure substances or not. So the first substance which they have given in this seventh question is ice. So this particular ice, even though it is in solid state, it contains H2O molecules in it. So only water molecules will be there in this particular ice. So hence ice can be known as pure substance. Coming to the second kind of substance, here they have given milk. Milk contains lot of fat molecules in it. So it is not a pure substance. So milk is not pure substance. So coming to the third material or the third substance which they have given here is iron. So iron as such is a pure substance. So the next substance which they have given here is hydrochloric acid. So in this particular hydrochloric acid, throughout that particular substance, the chemical composition will be HCl itself. So that's why even hydrochloric acid will be a pure substance. Coming to the next substance, that is calcium oxide. So calcium oxide will also have the same chemical composition throughout that particular substance. So calcium oxide is also a pure substance. Coming to the F substance, where they have given mercury. So mercury is also not containing any other element in it. Hence mercury is also a pure substance. So coming to the next substance in this particular seventh question, that is G substance, is brick. Brick is actually manufactured by mixing so many other materials in it. So brick is not a pure substance. So brick is not pure. So not a pure substance. Next substance which they have given in this particular question is wood. So wood also contains lot of other substances in it. So wood is also not pure substance. So the next substance which they have given here is air. So air also contains lot of chemical substances, lot of gases in it. So air is also not pure substance. So in this particular question, ice is a pure substance, iron is a pure substance, HCl is a pure substance, calcium oxide is pure substance, mercury is also a pure substance. Coming to the eighth question, here you should actually identify which kind of mixtures are known as solution. So the first mixture which they have given here is soil. So soil is an heterogeneous mixture, but the definition of solution states that solution is a homogeneous mixture of solute and solvent, but soil is an heterogeneous mixture. So soil is not a solution. Coming to the next mixture B, that is seawater. So in seawater there is a homogeneous mixture of salt in water. Hence seawater can be known as a solution because there is a homogeneous mixture of solute and solvent. Coming to the next mixture, that is C mixture, that is air. So in air 80% nitrogen gas will be there and remaining gas will be mixed in that particular nitrogen gas, that is oxygen, carbon dioxide and other noble gases. So all these other gases will act as solute and nitrogen gas will act as solvent. So there is a homogeneous mixture of this gas in this particular air. So air is also considered as a solution because it is forming homogeneous mixture. Coming to the next mixture in this particular 8th question, that is coal. Coal is again a heterogeneous mixture, so it cannot be a solution. Coming to the next mixture, that is soda water. So in soda water, carbon dioxide gas is homogeneously mixed in water. Hence, soda water is also an example for homogeneous mixture of solute and solvent. Hence, soda water is also a solution. Here, soil is not a solution and coal is not a solution. Apart from soil and coal, seawater, air and soda water are examples for solution. Coming to the 9th question, here also they have given certain mixtures and you should actually see which particular mixture will show Tyndall effect. So the first mixture which they have given in this 9th question is salt solution. So salt solution is a homogeneous mixture of salt in water. So salt solution will not show the Tyndall effect. So Tyndall effect is not shown in salt solution. Coming to the B question in this particular 9th question, there they have given milk. Milk is an heterogeneous mixture. So here milk shows Tyndall effect. So copper sulfate is also an example for solution, that is there is a homogeneous mixture in this. So hence this also do not show or not show any kind of Tyndall effect. Coming to the next mixture, here they have given starch solution. Even starch solution is an example for heterogeneous mixture. Hence starch solution will show Tyndall effect. So here milk and starch solution actually show Tyndall effect, but salt solution and copper sulfate will not show Tyndall effect. So here only milk and starch solution are answers for this particular 9th question, where milk and starch solution shows Tyndall effect. Because here milk and starch solution are forming heterogeneous mixture in it. Also they are examples for colloids. So colloids show Tyndall effect. Hence milk and starch solution show Tyndall effect. Coming to the 10th question, you should actually classify the given materials as elements, compounds and mixture. So here you all know that element is a single chemical substance. So if you take an example of sodium, so sodium means only sodium will be there in it. So that particular substance can be known as element. So if that particular sodium is forming bond with chlorine and there is an NaCl formation, so here there is a chemical interaction between two different elements. So that will actually give you a compound. So now if you actually mix NaCl and ammonium chloride, then there will be mixture of two different salts. They are not forming any kind of chemical interaction or chemical bonds between them. Hence, they will be known as mixture. So this is actually difference between elements, compounds and mixture. Based on this particular knowledge, you should actually differentiate these particular materials as elements, compounds or mixtures. So the first substance which they have given in this particular 10th question is sodium. So sodium is an example for element. So sodium can be known as element. Coming to the next substance in this particular 10th question, there they have given soil. So soil is an example for mixture because lot of elements or compounds are mixed together in this particular soil. So soil can be an example for mixture. So now coming to the next substance, there they have given sugar solution. So sugar solution is also an example for mixture. Coming to the D question, here they have given silver. Silver is an example for element. Coming to the E question, here they have given calcium carbonate. Here there is no independent chemical. There are multiple chemical elements which are present in this particular calcium carbonate. Hence this calcium carbonate is not an element, it is a compound. It is also not a mixture because there is a bond formation between these particular elements which are there in compound, in this particular calcium carbonate. Hence this can be known as compound. So if you see the other substances, there they have given tin. Tin is also an example for element. Silicon is an example for element. Coal is an example for mixture. Air is also an example for mixture because in air we have like lot of other gases mixed together. So air is an example for mixture, and also soap is an example for mixture because lot of chemical elements and compounds are mixed together in a different ratio. to form this particular soap material. So soap is an example for mixture. Methane, in methane you have CH4 where there is proper bonding between carbon and hydrogen. So it is not a mixture, it is actually a compound. So CH4, that is methane, is a compound. Carbon dioxide, that is CO2, is a compound, and blood is a mixture because blood contains lot of chemical elements and compounds mixed together in it. So blood is an example for mixture. So coming to the 11th question, here they have given different events occurring. So you should actually see in which particular event there is a chemical change. So coming to the first question in this particular 11th question, there they have given growth of a plant. So during growth of plant, there is complete formation of new substances taking place during the growth of a plant or during the growth of human body as well. So that's why growth of a plant is an example for chemical change. So surely there will be chemical change during this particular growth of a plant. So coming to the B question in this particular 11th question, there they have asked rusting of iron. Even in rusting of iron, actually iron is reacting with the oxygen present in the atmosphere or in the water molecules. So that's why rusting of iron is also an example for chemical change where iron is converting into iron oxides. So the answer for this B question is that rusting of iron is also an example for chemical change. So coming to C question in this particular 11th question, there they have asked iron mixed with sand. So when you actually mix iron with sand, there will be no certain chemical change taking place. So it will be just a mixture. So that's why there is no chemical change. So there is no chemical change observed in mixing iron with sand. Coming to the D question in this particular 11th question, there they have given cooking of food. Even while cooking food, there will be lot of chemical changes happening inside that particular food. Hence, cooking of food is also an example for chemical change. So coming to the next question, there they have asked digestion of food. So even during digestion of food, there will be lot of chemical changes occurring in this particular food. Hence, this is also an example for chemical change. So coming to the next question in this particular 11th question, that is freezing of water. So here when you actually freeze water, here you are not changing the chemical state of water, you are just changing the physical state of water. So the liquid state or the water which was in liquid state is actually converted into solid state when you actually freeze that particular water. So you are changing physical state, not the chemical state. Hence there is no chemical change when you actually freeze this particular water. So now coming to the last question in this particular 11th question, burning of candle. So here burning of candle will also be responsible for certain chemical change because there will be a chemical reaction with the elements present in that particular candle with the oxygen which is present in the atmosphere. So that's why there is a chemical interaction. Hence there will be a chemical change happening to that particular burning candle. Hence burning candle is also an example for chemical change. So this is all there in this particular video. I have explained answers for all these questions in this particular exercise of second chapter in 9th standard science subject. So like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then please do subscribe to my channel and stay tuned with my channel. Thank you.